Okay, today I'll be explaining 10.5 water. Now let's begin with the structure of water. So water consists of two hydrogen atoms and one oxygen atom, both connected, like all of them connected by polar covalent bonds. Then as you can see here, there's another bond, which is the hydrogen bond, and it's the strongest intermolecular force. So it's like stronger than the dipole-dipole force and the London dispersion force. So why is water polar? That is because of the negative sign and the positive sign. And further later on, I'll explain more why water is polar. So if there's a linear structure, that's wrong. So the hydrogen, like the molecule of water, should be in a bent angular shape. It cannot be in a linear structure such as this one. This is wrong because the two opposite equal forces will cancel each other. So as you can see here, particles in a liquid water and the particles in a solid water. So as you can see here, the particles in liquid water, there's less volume, there's less space, so there is more density. But then here, the opposite, there is more volume, making more space, forming rings, and the particles are like the molecules are in a hexagonal structure. Okay, so the ice like consists of water molecules in the hexagonal arrangement. And here, so we said that there's more volume, and so there's less density. Now we have heat of fusion. Now heat of fusion is the energy we add to a solid to change it to a liquid. But then we have the heat of vaporization is the energy added to change liquid to vapor, like from vapor, you know the word vapor, vaporization. By breaking the bonds. Okay? So as you can see here, we're breaking the hydrogen bond between those two water molecules. Now at room temperature, pure liquid water is transparent, odorless, tasteless, and almost colorless. Now we have the molar enthalpy of fusion. You can it's represented by delta HF. It is the energy required to melt or freeze 1 mole of a substance at its melting. Then we have the molar. Now the molar enthalpy of fusion of ice is relatively large than the molar enthalpy of other solids. Water depends on volume as it freezes because its molecules form an open, rigid structure. Now ice floats because it has lower density. And also later on I'll be explaining why ice floats. Now, molar enthalpy of vaporization is the energy required to vaporize 1 mole of a substance. Now, both the boiling point and the molar enthalpy of vaporization are high compared with those of non-polar substance of comparable molecular mass. Now, steam is the vaporized water that stores a great amount of energy. So that's why it really hurts when steam touches the surface of our hands. It's because that's why it's really hot, because it stores like a lot of energy. Now we have here practices. Now it will always be given like the molar enthalpy of fusion of ice, which is 6.009 kJ per mole. Then the molar enthalpy of vaporization, which is 40.79 kJ per mole. Now the first question is, what quantity of energy is released when 506 gram of liquid water freezes? So first of all, we have the given, which is the mass, and we also have those given here. So first of all, let's convert. So it will be like exactly. So we convert. So it's 506 over 18, which is the H2O. That's the molecular mass of H2O, which is 80.02. Okay. Then we have here it will be 28.08. Now after that, we would put 1 mole here, and then we would put here, because here they're asking is freezes, so it's 6.009. So we'll put 6.009 here, and then the 20.08 here, and then this is the unknown, or let's say the x. So we cross multiply. X will equal to 28.08 times 6.009, and the one, so it's just be the same thing. So X will equal to 168.7 kJ per mole. That's the answer. Now we move on to the second question. So here it says, what mass of steam is required to release 4.97 times 10 to the power 5 kJ per mole of energy on condensation? So here they're asking steam, so they meant vaporization. So we're going to use the 40.79. So let's do first, here we don't convert. First of all, we don't convert. They're asking for the mass. So first of all, before converting, we need to find the mole. So we have 1 mole, and then here we have 40.79. And then here's the unknown, or the X, and then here we have 4.97, which is this, times 10 to the power 5, cross multiply, X will equal to 4.7. So the answer would be 1284.36. So we use the scientific notation 1, 2, 3, 4. So 1.2 times 10 to the power 1 gram. Again, 1, 2, 2, 3, 4. Okay, so that's the answer. Now let's go to the section formative assessment. Now the first question is, now white water molecule is polar. Now that is because, as I said before, the bent angular shape of the water molecule, okay, and the other reason is because of the large electronegativity differences between the atoms of oxygen and hydrogen. So it results in the polarity. Now the second question is, how is the substance of water responsible for some of water's unique characteristics? The answer is the structure allows for hydrogen bonding. That results in the formation of molecular groups that it produces a high enthalpy of vaporization, boiling point, and a high enthalpy of fusion. Now describe the arrangement of molecules in liquid water and in ice. Now there are intermolecular hydrogen bonds in both. Now the liquid usually has like 4 to 8 molecules per group. That's in the liquid. But then in the solid, all the molecules are arranged in a hexagonal structure. So the particles in liquid, in liquid water, are more in more motion, because there's less volume. Okay, so it's more chaotic, and there's more chaos. Then we have the solid water. The particles there are they're moving in less motion, and it's more organized. Now another question is that the fourth question, but it's not written here. It's that why does ice float? Now that's because ice has low density. So for example, and what is the phenomenon, and why is this phenomena important? That's because in lakes, for example, when ice water freezes, it forms at the surface of the liquid, so it insulates the water below it, not killing, it prevents the freezing of other animals, the living animals. So if the water, if the solid or the ice was it was more dense, if it's more dense, it was gonna form on the bottom of the lake, so below, inside the water, so below the ground, near the near the earth, so on the ground. It would it would kill the animals. It will kill them. So it should form on the surface of the liquid, not in the bottom. So it could prevent the killing of the animals. So there are more questions, and for the rest of the questions of the formative assessment and their answers, you could check www.chemistryology.webs.com. And thank you, and I hope you enjoyed. Thank you.